Now the last part. Here three basic rule of calculus which is to be applied here. First one is differentiation. Here ddx of a into x to the power b, where x and x, this one is variable, only x is variable, other remains constant. So how to perform? Very simple. It is equals to, at first write down this constant a, then this constant b into x to the power, this power reduces by 1, it is b minus 1. Clear? Very simple. Let me give you an example. If it is given ddx of x cube, it is 4x cube. So it is equals to 4 into this 3, then x to the power 3 minus 1 gives you 2. It is equals to 12x. Very simple. Now this can be assumed as the reverse process of differentiation, that is integration. It is also very simple. Here a into x to the power, this power here, the power reduces by 1, so here the power must be increases by 1. It will be x to the power n plus 1 by n plus 1, and here a constant is to be placed, c. Very simple. If you are given integration of, say, 2x to the power 3 dx, it is equals to 2 into x to the power 3 plus 1, that is 4, by 4 plus a constant, it is equals to x to the power 4 by 2, or half x to the power 4 plus c. It is definite integration. So it is also one kind of integration, but the value of x having very low value and high value, that means a lower limit and upper limit. It is to be done by means of same way. It is m into x to the power n plus 1 by n plus 1 plus c. The basic integration can be done from a to b. But c is constant now. So c can't be placed here, as in whenever this very function operating within this limit, then for lower limit and upper limit c will be common, so it will be cancelled out easily. In that case you can't write down c. So next step is to be followed likewise. It is equals to m by n plus 1 into upper limit b to the power n plus 1 minus a to the power n plus 1. Clear? Very simple. If you are given, suppose integration of 2 to the power 3 x cube dx, it is equals to x to the power 4 by 4, lower limit 2, upper limit 3, it is 3 to the power 4 minus 2 to the power 4 by 4. Very simple, isn't it? Now you know that velocity equals to rating change in position, or rather displacement by time. Very small displacement is considered as ds during time dt, and same is applicable for acceleration also. A, it is equals to dv dt. dv is change in velocity, whereas dt is time. So, and you can write down j equals to charge equals to dA dt. Very simple. So, if you uses this equation, ds equals to v dt. Clear? Suppose if v remains constant and you integrate these two parts, then ds equals to integration of v dt. Integration of ds gives you net displacement. there may be a constant here plus S0. V dt, if V remains constant, then it is equals to only Vt. You have to subscribe S or rather a constant in any side. Clear? So it can be written as S plus S0 equals to Vt. If displacement is taken from that very point where the particle begins to start, that means displacement is counted from that very point, then S0 becomes 0. In that case, you can write down S equals to Vt. So for uniform motion where V remains constant, then the equation will be S equals to Vt. Where acceleration remains constant, then dV, by using this equation, dV equals to AdV. By integrating both sides, you can write down integration of dV equals to integration of AdT. Integration of dV means it must be V, change in velocity, that means V minus U, total change in velocity equals to A multiplied by total time taken. So it is equals to V equals to U plus A. So if you use this equation here, then what will happen? The entire part can be rewritten likewise. ds equals to U plus AT dt. Now integrating both sides, you can write the integration of ds gives you only s equals to u dt, integration of u dt plus integration of at dt. It gives you only ut plus it will be at square. T having power only 1, so it must be t square by 2 plus a constant c. Same, if displacement is measured from that very point where is called reference, then c will be 0. That means at t equals to 0, the particle is at 0 point. So in that case c will be 0. In that case you can write down s equals to ut plus half ut square. See, the same equation can be derived with the help of calculus. So calculus is not a special thing, but it is analyzing the same process or analyzing the same thing with the different process. Clear? So just as a beginner, you must know these very small or very little things of calculus. In later classes, I will discuss this part in Excel. Clear? Where is it? S equals to ut plus half ut square.